Good day, everyone. Today, I am here to discuss on how to draw the Lewis structure of molecular covalent compound. But before that, let's have first a recap about writing the formula of molecular compounds formed by the non-metallic element of the representative block. Writing a molecular compound is writing a formula of two different non-metals. The first thing that you have to do is take the names of the compounds and express them into a chemical symbol, and then take the prefixes and place them as the subscripts, where the prefix for 1 is mono, the prefix for 2 is di, the prefix for 3 is tri, the prefix for 4 is tetra, the prefix for 5 is penta, the prefix for 6 is hexa, the prefix for 7 is hepta, the prefix for 8 is octa, the prefix for 9 is nona, and the prefix for 10 is deca. So now, let's proceed in our discussion. Lewis structure are usual representations of the bonds between atoms and illustrates the lone pairs of electrons in molecules. There are 5 easy steps in constructing Lewis structures. The first one is find the total numbers of valence electrons. For example, the calcium carbide. The calcium carbides are expressed in the formula of CaC2. Since calcium is in the second group, its valence electrons was 2. Carbon has a valence electrons of 4, but since it says that there are 2 carbons in the formula, we have to multiply the 4 valence electrons by 2. So, carbon has 8 valence electrons, while calcium has 2 valence electrons. We just have to sum all the valence electrons in each element. So now, we have 10 valence electrons at all. Step number 2. Put the least electronegative atom in the center. Atoms that needs the most electron becomes the center atom. For example, the H2O. Note that hydrogen always goes on the outside of the Lewis structure. Step number 3. Put the 2 electrons between atoms to form a chemical bond. For example, the hydrogen and chlorine. We know that hydrogen and chlorine has 8 valence electrons, so we put the first 2 in the middle of hydrogen and chlorine. It is important to put the 2 valence electrons in the middle to show that hydrogen and chlorine are chemically bonded now. Step 4. Complete the octet on the outside atoms. For example, the hydrogen and chlorine. Hydrogen has only 1 electron, while chlorine has 4 electrons. For the chlorine, there are 6 remaining electrons, so we have to put it around the element. And now, we complete the octet for chlorine. Hydrogen has only need 2 valence electrons for full outer shells. So hydrogen has 4 outer shells with no valence electrons, while chlorine has a complete octet. But sometimes, there are cases that you already use all the valence electrons but still you haven't completed the octet. And that's the step number 5. If central atom does not have a octet, move electrons from outer atoms to form a double and triple bond. If we run out of valence electrons, move some valence electrons from the outside to the inside and share them to form a double and triple bond. For example, O2. If I follow all the rules and count all valence electrons, I have 12 valence electrons. If I fill the bond and complete the outer shells, I end up with this situation where I have the octet on one side while the other side is incomplete. There are no valence electrons left. And to solve this problem, remove the 2 valence electrons and place it on the middle to form a double bond. Still, only 12 valence electrons was used, but now we formed the complete octet.
created using Powtoon.